Alright, welcome to Frank Teaches DevOps. My lovely viewers. Yes, compliments of the season. Compliments of the season. Frank Teaches DevOps wishes our fans good health, good life, long life, and prosperity, and good understanding of DevOps, and above all, the Holy Spirit that will lead and direct your path. Thank you. So guys, like I earlier mentioned, and I'll keep mentioning, that Frank Teaches DevOps is transitioning into DevSecOps, and we would be, from time to time, giving us tips of the iceberg, all right, concerning security. All of these is necessary because we are starting DevSecOps come March 2024. Frank Teaches DevOps will be starting DevSecOps, right? And for that reason, we are just creating an awareness, all right? Creating an awareness by setting up these important but necessary videos, all right, on security. All right, we're doing it across all borders: cloud computing, Kubernetes, Docker, you name it, guys, you name it. So against, all right. Yes, guys. Yes. So now, today's topic is how to mitigate against privilege escalation on Docker containers. Yes, you heard me right. 99 or 98%, let me put it, guys, 99% of Docker containers out there are prone to attack. 99% of Docker containers don't play. Docker containers out there are prone to attack. They are prone to attack. Take it from me, guys. Take it or you leave it. All right. So now in today's video, all right, I just want to show us two things. I just want to use two Linux features. It's a Linux feature, guys. I've not even started defending or providing defense, all right, counter defense to Docker containers, protecting Docker containers. This is just the peripheral. This is just the surface, right? So there are two features. One of that feature is called CGroup. Yes, you heard me very well. One of the feature is called CGroup, and the other is called Namespaces. Namespaces. Yes, I will show us how. Now I'm going to start with CGroup. So with CGroup and Namespaces, I should be able, to a very large extent, all right, reduce privilege escalation on a Docker container. Now with CGroup, I should be able to, I'll explain to you guys, man, to protect my Docker image against, protect your Docker container against DOS attack. DOS attack, distributed denial or denial of service attack. That's with CGroup. Then with namespace, I should be able to protect your Docker container against privilege escalation attack. All right, I'm going to explain all of that. All right, so I'm going to start with CGroup. What are CGroup? Thank you. CGroup. So what are CGroup? CGroup is a Linux kernel feature, all right, that allows us to limit the access that processes and containers let me bring it down. Containers have to system resources such as CPU, RAM, inputs, outputs, process, and network. So CGroup is a Linux kernel feature that allows you to limit the access that processes and containers have to system resources such as CPU, RAM, IOPs, and network. I will explain this. Now, let's assume, all right, let's assume that you have a container. You have a container. This container is allowed to run maximum processes, n number of processes. All right, this container, all right, is allowed to run n number of processes. It means that there is no limit to the process this container can run. It means that there is no limit to the number of processes that this container can run. So it means that if this container is being compromised, if this container is compromised maybe by an attacker, this container, let me look for an icon for hacker images, transparent, let me look for something. This, can I get that? I need an image. Perfect. Let me use this guy. Great. Copy image, paste that guy there, paste him there. Oh, okay. Let's say this container has been compromised So if this container is compromised, it means that this container is going to run, this guy is going to run random processes. This guy is going to run random processes. So the moment you run random processes, all right, on this container, all right, is going to overpower. It's going to what? Overpower the container. Once this container is overloaded, right, it's going to overload. Let's use that word. It's going to overload the container. The moment the container is overloaded, all right, it will make the container go out of service. Container will now go what? Go out of service. Now look at this. Now when you create a container, by default the container comes with, there's no limit to the number of processes that can be run on that container. So once that happens, and if an attacker compromises that container, this attacker is going to run random processes, and these random processes is going to overload the container, right? And once the container is overloaded, it's going to what? Shut down the container. And the moment the container is shut down, the container will be experiencing out of service problem. All right, so the container will be overloaded. Once the container will be overloaded, it will cause what we call what? DOS, denial of service. All right, once you are denied of that service that the container provides, then you can't have access to that container. So this is a problem to 98% of containers running on the internet. They are not secure. They are not totally secure. They are exposed. All right, so we are going to be using CGroup to limit what? The number of processes that anyone can run in that container. Now let's check it out. I have a Docker, I have a server. So on this machine I have installed Docker. So let me do something. User mode, let me add this user to my Docker group. Docker EC2 user added, new group. Perfect. All right, so this guy can run Docker commands now. Great. Sudo system docker.service. all right, now Docker images. I still you can't let me exit and come back, because it's a member now. You should be able to run Docker commands, images without me. Perfect guys. So now I want to demonstrate what I just explained now. So for that, let's just demonstrate it. So I'll be creating a Docker container, docker run dash dit. The name will be Acorn. Then the image will be from Alpine, right? So I'm creating a Docker container. So if I say docker ps, I have a Docker container now running, right? Great. So now I want to demonstrate CGroup. I want to show us the CGroup, how CGroup looks like. So for that, so I've created this container. All right, now I'll go to this file system. So I'll sudo dash I. Now I'll say cd into sys file system CGroup. Okay, look at where I am now, ll, and I will go to PIDs. Now inside of PID there's a file. I'll go to Docker, I'll do Docker. Now inside of Docker there's a file called pids.max. Remember, this value, this thing you're seeing here, is the container that we just created. You can see the string is the same thing as what we have when we created this container. Look at F7 F8 F7 F8. All right, so I wouldn't want to go into how Docker images containers are stored locally. That is a different topic in my DevOps program already. So I'm not bringing. I won't be bringing. I won't be talking about how Docker images are stored locally. That's with the storage driver. Docker uses a storage driver called overlay 2. I wouldn't want to go into detail, guys. This course is solely for security. I'm building on on DevOps. I'm building on Docker already. So this is Docker security. All right. So great. So if you need to read more about how Docker images are stored locally, then you have to look at overlay 2. So overlay 2 is a storage driver for Docker. I wouldn't want to go into that. Now there's a file called pids.max. Now if I open this file now, let's see what's in that file. Cat pids.max. You can see this is the process. This is what this thing means is that every container is given to run maximum number of processes. There's no limit to running processes in this container. All right, in this container. So now if I go into this guy, this container that I just created, now under this container there's a file called pids.max. This is the PID that controls this particular container. So if I do this cat now, pids.max, I will see that the value of the number of processes that you can run in this container is set at what? Maximum. This thing is dangerous. This maximum you see is dangerous because, as we illustrated, if this container is compromised by an attacker can what? Use his privilege and run random processes. He will be able to run maximum processes. Now let me illustrate that now. Let me illustrate it. Now look at this. Let me open a similar let me open a side by side virtual instance. It's the same instance. All right, so I want to show us something. Now I'm going to run docker stats. Look at now. So currently I have this container and the number of process on this container is just 1, right? Now I want to increase this number of processes. Now this is what I will do. I will exec into the container. I will say docker exec -it. The container name is acorn. Then it uses this shell. Perfect. I'm now inside of this container. So I want to run processes now. So this is what I will do. I'll say sleep 200 and sleep 200. I'm running all of these processes in the background. And so let me copy and paste. Copy, okay, paste, paste. So how many processes have we now? 1 2 3 4 5 6 7 8 9 10 11 12 13 14. So if I hit enter, now look at what's happening now. Let's go and check our stats. Look at now, I am running 16 processes. Guys, this is dangerous. You can see I'm running 16 processes in one container. Let's go back again. Now it doesn't end here. Let me keep pasting. Paste. This is what's going to happen. This guy is trying to flood the container. He's an attacker because he has what? Privilege. Now let's check the Docker statistics. 102 processes are running in my container. Let's continue doing it. Guys, you need to join my class, DevSecOps. Let's continue doing it. Now let's go back now. Let's check how many processes are running now. Let's check. Say 102. Okay, I've not hit enter. Hit enter. Perfect. Now come now. We have 162 processes. This is how this guy will continue. This attacker will keep running random processes. He will keep running random processes until this container becomes overwhelmed. Once this container becomes overwhelmed, it's going to shut down the services running on that container. And at the end of the day, the container legitimate users will not be able to access the services running on that container. Now there is a way we can avoid all of these. All right, so I'm going to exit. I've exited, right? I've exited. Now come back. I want to avoid all of these. I want to create another container, similar container, but now I'm going to limit the number of processes that could be run on that container. Let's do that, guys. So I'll say docker run dash dit. The name of its container will be CGroup CGRP. All right, then I will use a flag --PIDs limit. I want to limit the number of processes to 4. You can only run 4 processes in this container. Anything more than 4 will not be acceptable. Then the image name is Alpine. Created. Take note of the ID 4799. So if I now say docker ps, this container CGroup has been created. Now let's look where we are. Let's go back to /sys /file system /CGroup then /PIDs then /docker. Now under docker we should see the container. This is a new container that's been created. So let's go into that container. So I'll say what? cd into 47. I'm now inside of this container. Now let's view the PIDs.max file. If I do a cat PIDs.max, we should see 4 processes and not maximum, and not set to maximum. 4 number of processes. It means that this container is only allowed to run 4 processes. Now let's check now. This is the container CGroup. All right, under our docker statistics we are seeing what? Just 1. Now let's try to exec. I will do a docker exec -it into where the container name is CGroup, then sh what is it? Okay, let's see. It's 1 now. It's 1. Connection reset by peer unknown. Failed to start container process. Okay. Docker exec -it, the container name CGRP, then bin sh. Should go now. Okay, all right. So I know. Okay, so let's increase the number of processes instead of just 4. All right, so I'll say docker run -dit dash name is CGroup, then the limit -PIDs limit is 6. All right, then Alpine, the image name is Alpine. Great. So now let's do a let's go in there cd 02. Then if you cut this PIDs.max, we should see that the number of processes is what? Is 6. Let's check our docker statistics. So far it hasn't increased. That's it. So now take a step backward. Now let's do a docker exec -it, container name is CGroup, then sh. Now we are now inside of this container. You can see the PID should increase to 2. All right, now if I run that same command, sleep 200, or let me say 600 this time around, and sleep 600, and if I hit enter, now I've been able to run about 4 processes. Right, now let's make it 6. Sleep 600, and that's 5. Sleep 600, and that's 6. Now let's check. Come over here, 6 processes. Now try to increase it now. Sleep 600. It says what? Error, can't fork, resource temporarily what? Unavailable. I'm trying to run more than 6 processes that I have specified in the container. Alright, rather I'm getting this error, can't fork, resource temporarily what? Unavailable. So with the limit, right, with the help of CGroup, we can actually limit the number of processes that could be run in a Docker container. I hope we've been able to explain what CGroup is and how to mitigate against overflowing a Docker container. I hope this setup, all right, will be helpful to someone somewhere else. All right, so great. So the next on our table is what? Namespaces. So we're going to look at namespaces. All right, so we're going to see how to use namespaces to reduce privilege escalation. All right, to reduce what? Privilege escalation. So now, what are namespaces? The same way, let me copy this guy, copy and paste. A namespaces are a feature, a Linux kernel feature. All right, a Linux kernel feature that isolates, right, that provides, I will say, that provides isolation to the container from the host machine. Now this is the behavior of namespace. Now assuming I have the host machine, I'll say the host VM. All right, now on the host VM I have a container running. Container. Now without implementing namespace, right, without implementing namespace, this host VM and this container cannot be isolated. All right, it cannot be isolated. But the moment this is without a namespace setup. This is without a namespace setup. All right, then this is with a namespace setup. There will be an isolation between the host VM and what? The container. So now before I go into the nitty-gritty, let's first of all look at different types of namespaces that we have within the Linux kernel, within the Linux file system. Like we rightly mentioned, what are namespaces? Namespaces are Linux kernel feature that provides as isolation to the container from the host machine. All right, the host machine. It separates the container from the host, so that anything you do within the container remains within the container, and anything you do within the host machine, it remains within the host machine. There is no free flow of activity. All right, there's no free flow of activity. So now, before we go into the nitty-gritty, let's look at different types of namespaces. Now we have the PID. So this is namespace for processes. All right, for processes isolation. If you want to isolate processes between your container and what and the host machine, you use what? The PID namespace. The another is the net namespace for network isolation. Namespace for network isolation. The next one is IPC. So IPC stands for interprocess communication. All right, so this provides isolation for IPC processes. All right, then we now have the MNT, which is, it provides file system mount, right, isolation. File system mount isolation. Then we have the next one, which is what? UTS. So this isolates kernel and version identifiers. So this is used to isolate kernel and version identifiers. Okay, then the last but not the least is user ID namespace. So this user ID namespace is used to is a namespace for privilege escalation. Is to isolate privilege escalation. Now, to isolate privileges. Now we will be we are just going to be interested. We are going to only talk about the user ID namespace. All of these namespaces, our concentration will be only on what? The user ID. We are going to see how we can protect our Docker containers from privilege escalation, even when the Docker container is being compromised. Even when it is compromised, the attacker won't be able to escalate its privilege, and I am going to demonstrate that and show it to us. Okay, now let's now bring up our guy. Let me exit. CO, I've exited. All right, I'm going to create a new container, and I'm going to mount the root file system on the container. So meaning that I'm going to have the entire root file system inside of the container. Okay, so this is what I will do. But before then, let me explain something. Now, what user ID namespace? This is what I want to explain. Now, what this guy says is, right, if this guy is not set up, by default, when you create a container, now look at this. Now if I do a docker exec into this container, number of processes still on 5, so it did not allow me to log in. Okay, let me go to the other one. The other one was Acorn. All right, inside. Now if I type ID, look at now, it means that this guy is running as root, right? Perfect. Now that goes to say that if this container is compromised, the attacker can easily gain access into the host machine. Now look at this. Now let me explain. Copy. Now what this thing means is that if this container is compromised, let's copy those copy, paste. Okay, now if this container is compromised, this container has been compromised, and once this container has been compromised, knowing fully well that this container has root privileges. This container has root privileges. All right. Now, the attacker is going to leverage on the root privilege to gain access. Gaining access is going to gain access into what? To the host virtual machine. So once this guy gains access to the whole virtual machine, the entire system is shut down. He gained access. So this flow will now be two-way communication. He has used the container to gain access into what? The virtual machine. So from this instance, he will be able to escalate his privileges to other virtual machines. He will be able to escalate his privileges to other instances that are hosted within that network. So this is what will outplay within the system. But now Docker is telling us that we can actually, so okay, before I go into that, now what this thing means is that the root user access on the host VM is equivalent, is the same thing as the container, the root user access on the container. So it means that if this guy has root access here, where is that thing? Copy. So it means that if this attacker has root access here, he will equally gain root access on the host machine. He will equally what? Gain root access on the host machine. Now, we want to discourage this behavior. So for we to be able to discourage this behavior, we are going to what? Make use of what? The user ID namespace, such that even if the attacker has root access on the container, he should not be able to have root access on what? On the host machine. You shouldn't be able to have root access on the what? On the host machine. Now, to set this up, but before we set this up, let us show us something. Let me exit. Okay. Now, let me create a file. Echo. I am from the host VM. Let me call this file secrets.txt. Look at it. Now I've created a file called secrets.txt. Now I want to create a container. This is what I will do. Docker run -dit. Let me just exec into the container at once. I want to show something. I'm going to mount the entire root directory. All right, I'm going to mount this guy column into a folder called shared directory inside of the container. Now the name of the container will be namespace con, which is nscon. Then the image is alpine. All right, great. Now, because I created this guy, I asked Docker to give me what? A shell. All right, so I have a shell now. So if I do ls-l, you can see that I have the entire root file system mounted. It's mounted on shared, right? If I go into shared now, change directly into shared. Now let's list the content of shared. You can see I have everything from the base machine. right? Which I mounted the root file system inside of what? The container, right? So I have it, everything here. So if I go into this directory now, root, change directory into root. Now if I list now, I should see the file called what? Secret.txt. Now if I open this file now, that's this file, right? Now I want to write into this file. Know fully well that this file is coming from the root. I want to write into this file. So this is what I will do. I'll say echo I am from the container and secret.txt. I will override it. Let me override the content. It was successful. Let's check. Cat secret. Yeah, let me exit now from the container. I've exited from the container. Now let's check the content of that file in the host machine. You can see I am from the container. This has just explained to us that the moment the attacker gain access to the container, the attacker can what? Can escalate, can again gain access to the host VM. So it means that he can now escalate his privilege. What I just demonstrated is a typical example of what will happen if this container is being compromised. So for we to avoid all of this, we would be making use of what? User ID namespace. All right, user ID namespace. So let's see how to what? Set up user ID namespace. Okay, great. Now for that, if you go to Google, let's go to Google. Let's type docker namespace. Namespace. Isolate containers with a namespace, with a user namespace. Let's open this guy. So I want you guys to read about isolating containers with user namespace. All right, read about these guys. All right, about remapping and subordinate user and group IDs. So read about these things, all right, so that you have a proper understanding, all right, of what we are trying to achieve. Okay, great. So all right, so there is a user, and let's leave that. So make sure you read about this this document from Docker. All right, I'll close it and I will close it. Great. So now this is what I want to do now. So for we to achieve this now, I'm going to delete all the containers that I have. All right, so I'll say docker rm-f. I'm deleting all the containers that I have. Docker ps dash. All right, so I'm deleting everything. I've deleted all the containers. Docker ps dash a. I don't have anything, right? Perfect. I'm going to stop docker system ctl stop docker. I'm going to stop docker. I'm going to stop docker. All right, so we are going to stop docker stop. Okay, perfect. Okay, docker has been stopped, so I will exit. Even if I don't exit this guy. All right, so now this is what we want to do. Now we want to enable a user mapping. All right, now what I want to do is, let me go to a user mapping. Now I want to create a user mapping such that we are going to be mapping a user on the container. That user by default is called docker remap. All right, we are mapping this user to a user on the host machine, which is the root. All right, so now what this thing means is despite that this user is going to have root access, this user will operate in its own context. Similarly, the root user on the host machine is going to what? Operate within its own context. So nobody will be interfering with either user's context. Alright? So this was this is what's happening. So as you can see, I have stopped Docker. So I'll now enable this feature. Alright? This feature of user namespace. Right? User namespace. So to do that, I will say docker d -- user ns - remap. User ns - remap is equal to default. Now there are two files that this process is going to create. Now this process is going to create two files. It's going to create a file under etc called sub uid. There's a file, but this file already exists. Sub uid and sub gid. These files, they are not supposed to exist. It is when you run this command, then they will now create an entry inside of this file, right? But this was what I encountered, and I realized that the files already exist. Okay, so if I run this command, we're going to have some challenges, but let's look at the challenge and resolve the challenge. All right, so I'm going to say docker d -- user ns - remap default. Then I'm going to run this on the background. So let's check. Oh, sorry guys. Okay. It is exiting. Let me. So okay, we need to run this that command as an unprivileged user. Okay, even if you run as a privileged user, that's okay. So docker d user ns remap default. Now this is what we are having. User namespaces ID ranges will be mapped to SUID sub UID and sub GID ranges of Docker remap. Can't create ID mappings. So that's the error we are having, the challenge we are having. No sub UID ranges found for user Docker remap. Okay, so it is exiting. The process is exiting. So this is what we'll do. What we'll do is we are going to create a user. All right. We could use the default, which is Docker remap, or we can create a new user. So for this context, I can say user add test. So I've just created a test user. So I'll now go into this file etc sub uid. So in this file, I'm going to create a mapping for the file. So I'll say test column. Now let's go back to that post, that documentation. I'll say docker namespace. Now there's a range of value you can pick from. All right, you can pick from the initial value from this value 2310772, all right, to 65536. Okay, so this means that test user is assigned a subordinate user ID range of this and the next this integers in sequence of this. UID this is mapped within the namespace, within the container, in this case as UID 0. Okay, so what's happening that this value is mapped to a UID 0 within the container, all right, and this which is an increment. All right, so if you need to create another user, you have to increment this value by 1, which is 72, 73. If you need to use another one, 74, 75, just like that, and that value will be mapped to a UID within the container of what? Of 1, and so on and so forth. So what Docker is telling us that we can create a user, all right, and assign the first initial value, range of value to it, and the integers in sequence, all right, the integers in sequence. So this is what we'll do. We'll come back to our terminal, all right. The test user is, the first value will be 231 072 231 072 column 65 536. All right, so I'm going to escape, save and quit. I've created an entry in that sub UID, so I'm going to create another entry in sub GID. So let's cut the content. Let's cut etc sub UID. Let me copy this guy. Now go into sub GID and paste that content. Perfect. Escape, save and quit. Now let's now rerun this Docker mapping, user mapping, sorry. So I'll say docker d dash dash user namespace dash remap is equal to the test user. Now we're not using the default user. The default user will always default towards a doc remap user, right? When you use default here, it always results towards this doc remap user. But when you're using your own user, you have to create your user and create an entry inside of the file. Put ampersand, enter. So this is successful, right? So what we have done so far, we have created a user ID namespace. So once your environment is like this, then you can go ahead to create your Docker containers. So we have this now set up. Daemon has completed initializing, listening on this, what again? For this test user. Great. Now let's go inside now. Let's say now docker run dash it. The name is Acorn. Container, the image is what? Alpine. Enter. So now I have created this container. Let me exit. Let me remove the container. Docker, there's a way I should have created it. Docker rm-f Acorn. Deleted. Now I'm going to create the container and mount the entire root file system. So look at what we have here. I'm going to change this content. And from container, let me change the content. Let's say echo I am from the host VM into secrets. Now what do we have now? I am from the host VM, right? Great. Now let's go into that host VM now. Let's now create a container. Sorry, docker run dash it dash name is Acorn dash v. I'm mounting the root file system on a shared directory inside of the container Alpine. Great. This guy has been created. So if I check now, I should see a directory called what? Shared. Go into shared directory. I should see the entire root mount point, right? Then I'll go into what? Root. I'm inside. You can see now. You can see I can't have access to the root file system. Permission denied. I tried to cd into root. I'm having what? Permission denied. Now who is this user? ID. Even if this container is running with root privilege, it doesn't equate you to have access to the root file system coming from what? The host VM. So with this method, you've seen how we've been able to use the user ID namespace, all right, to restrict, to isolate the namespaces, to isolate the container namespace context from the host VM namespace context. So remember, before we could look at now, I'm having nobody. Before, when we did this, we were able to write into the root file system. Look at what we did here. I am from the container. We did this very well, successfully. Okay, we did this successfully, but now we can't do it anymore because of we are implementing you are using the Linux kernel feature called namespace to control privilege escalation. Privilege escalation. So with this being said, even if this container is being compromised, this attacker might not be able to gain access. He might not be able to gain access into the host VM. So with user ID namespace, which we explain here, we've seen how we have been able to isolate the container from the host VM, right? That being said, this is it for today's video, and I thank you guys. All right, I thank you for your support and all you have been doing for Frank Teaches DevOps. So to this end, we've seen how to mitigate privilege escalations, all right, on Docker containers using CGroup and namespaces. Thank you, my lovely viewers. Thank you once again. Compliment of the season, and see you in good health and hearty conditions in 2024. I love you guys. Have a nice day. Peace out.